get over it again once again. So once again, thank you for joining this call, and yeah, over to you, Mr. Nelson. Thank you, Mr. Nelson.
All right, thank you, everyone. Thank you, Daniel. I just like to clarify. This session is meant to be um, a a theory session and a practical session. So even though it is the last in the series, this is not the last class, right? The next class is going to be the same thing, but we'll get straight to demonstrating what we are going to talk about today. Does that make sense? Usually we will go through a concept, explain it, and then I'll show a code, right? I'll show how it works. Because of the complexity of the API gateway, it was not possible for us to do for us to also pack implementation into this session. Does that make sense? Right. So the implementation deserves its own class. It deserves its own, its own demonstration. All right. So let's get straight to it. Okay. Let me find a presentation mode. Anybody knows how to achieve presentation mode here? Anyone? Anyone? Okay, so let me start by asking who remembers any of the things we had talked about in the last two classes. Anyone? So unmute your mic and say something. Who remembers what we had talked about in the last two classes? Anyone? Who remembers? Please unmute your mics, or maybe I should start calling people's names. First of all, how many people were here for the last two classes?
Well, I think most of the people I'm seeing are quite new. Yeah.
Oh, really? So amazing. So this might be a bit of a challenge. Okay. Is there anyone here who was in the last class at least? Last class? Is there anyone who was in the last class?
No, I'm not sure, but I think people will join, subsequently. So probably people that were in the last class will join as well.
All right. Okay, so let's start. I'm just going to do a quick overview of maybe we should go. Maybe we should run through the. Maybe we should run through the last the last slides. What do you think? Just to refresh our memory, and then and then help us with it, right? So let's do that instead. How do you stop this? Okay, stop sharing. All right. Is that Elisha that I see? My goodness.
Hello. Good evening.
Goodness. All right. So today is going to be good then. Okay. I am currently sharing the slide from the last class for the benefit of those who were not there. So we're going to go through it very, very quickly because that's not the purpose of this class. So this is microservices, and we're just going to talk about what it is. Microservices it's just an architectural style that helps you build your application a certain way, right? But you're building it this time as a collection of services that are independently deployable, loosely coupled, right? So what do we mean by independently deployable? So you have the favorite example is an e-commerce application, where you have the product service, the checkout service, the payment service, the ordering service, the notification service, whatever, right? You build them as standalone applications, and because they are standalone applications in themselves, you can deploy them independently. By building them separately, you have what you would have successfully done is to decouple the application, so they are not tightly coupled. All right. This is some of the patterns. This is a picture of what that might look like. You have a delivery service, you have a consumer service, you have an order service communicating through an API gateway, and this pattern is what we are going to talk about today, right? Makes sense so far? Let's proceed. As a decentralized architecture, microservices mean that each services, of course, would operate on its own, right? And because they are independent, the primary way of interacting with other services would be to communicate with them through well-defined and well-documented APIs, I must add. Of course, these services are independent, right? Each service in itself is self-contained. It will most likely have its own database if that is the pattern that you choose, right? And then that service will have its own business logic that is unique to that service, right? In a large team, you would have the services owned by 2-3 people within a larger organization, right? And because the services are separate, and because the services are independent, you have the ability, you have the freedom to even decide what technology to use. And because they are separate and deployed independently, they can scale independently. Now, what does that mean? It means that if the order service, if we are approaching, let's say we work at Jumia, right? And then we have an order service, and then we are approaching Black Friday, what you call Black Friday. And from our record, from our history, we know that we have a lot of orders, right? Because people are trying to, of course, buy things on that day because they are slightly cheaper. Now, because we have known this, what we'll do is that we will replicate the order service, right? On that cluster, depending on where we are, how we are deploying it, depending on the CI/CD practice of the organization, we would make multiple instances of the order service. I don't know if that makes sense. Please, you can stop me at any time and ask a question anytime, right? This point is important. So because we expect we expect an influx of orders, right? We can create multiple. Yes. Okay, Elisha, go ahead.
Yes. So quick question from what you're saying, if I understand well, you're saying that even though we're having microservices, each service, I know the main aim sometimes of having microservices is to scale each part separately. Are you saying that we can scale this separately as they have more than one server for each microservices and introduce something like load balancing?
Sorry, take your question again.
Okay. When we say we are scaling each particular service independently, yes? And then we have a high peak period, maybe because of Black Friday, like you said. Can we now introduce something like a load balancer? I'm just trying to, because the idea I have for microservices is just maybe one server that the gateway communicates to. So can we bring in something like horizontal scaling on the microservices architecture?
Right. Good question. So this is a very important question. So you see, it depends on the pattern that our organization wants to employ to implement the microservice, right? So we can have a gateway, right? As a matter of fact, that's what we are going to talk about today, and that's a very important question. Elisha, I'd like for you to take note of it so that we can go back to it, right? If we are using the API gateway pattern, then on that API gateway would be a load balancer, right? There are several patterns. Down this slide, we'll see several patterns. if we are using the API gateway pattern on that service, right? You know, the gateway is a service on its own, right? It is responsible for a lot of things. Authentication, security, load balancing is one of the core functionalities of the API gateway. So if we are using API gateway as a pattern, then in some cases, instead of creating multiple instances of that other service, that API gateway would manage that load for us. Does that make sense?
Yes,
Lisa, does that make sense?
It does on a theoretical level, and maybe as you keep going down I'll understand more about it.
Yes. Okay. So once we get down to the slide, you'd see that was a very important question. Okay. So let's proceed. Of course, the services can be scaled independently, enhance scalability. In fact, this thing, I experienced it very recently, where we had to create, and it's crazy. You think scaling is a big thing. What I watched was simply duplicating that instance on a cluster. That was what I experienced, was just duplicating that instance on a cluster. And sometimes there can be a script that does that for you. Most of the newer services, AWS, GCP, and Azure can do this scaling for you automatically. That's a point to take note of. Now, remember, scaling can be horizontal or vertical, right? We'll talk about horizontal and vertical scaling another time. This flexibility is crucial for handling varying workloads efficiently. Now, I'd like for someone to ask a question about scaling so that we can do a deep dive. Okay. Now remember that we have different services, right? And because of what they do, the individual teams they have the freedom to decide what technology stack to use for each service. So if you have a recommendation service, for instance, you can say, you know what, the core application is built with Java Spring Boot, right? Let us even use Python for the recommendation service, right? Now, you would say, oh, well, if we are building the application with Java, how come we are using Python for the recommendation service? And the answer is because each service is built as a standalone application, right? We have the freedom to do that. And remember, with Dockerization, you can build anything with any stack and then put it in a container, and the container will communicate with other services. Does that make sense? Please unmute your mic and say yes or no. I'd like to get feedback, right? So that is what this point means. Because the services are different, because the business logic per service is different, we have the freedom, if we belong to a team, to say, you know what, let's use Scala, or let's use Python, or let's use or Go, right? That's what this means. CI/CD, the microservices encourage a DevOps culture, promoting continuous integration and continuous development practices. Of course, this will lead to faster development cycles and quicker responses to changing business requirements. So what is CI/CD? Continuous integration and continuous development. It's a practice that merges it's a DevOps practice, right? Development where development meets operation. It's just a practice that ensures that there's a cycle of there's a predefined and structured cycle of releasing software such that it will not affect business operations. So there's a pipeline. You build, you test, right? If it works, we push it into the pipeline and it will deploy automatically. If it fails, in fact, there's testing, right? It will do as part of the pipeline. There's testing. If the test fail, it will come back and then we'll reiterate, right? If it passes, then it will deploy automatically. Now, because you have independent services, we will not, if something fails, we won't have to bring down the whole application, right? We won't have to bring down everything. We will just take down that service, or power it down and then work on it and then redeploy. Single responsibility principles principle, meaning that each service has a very specific and well-defined responsibility or function. The CAT service just deals with CAT-related operations. This point is clear. In the modern software world, where we have principles that guide software development, one of the core principles is ensuring that functions and methods and modules do exactly what they are designed to do, right? If you have a class, that class should do exactly what it was designed to do. It should not, if you have a CAT class, for instance, that CAT class should have nothing to do, you should not have order related business logic in the CAT class. If the CAT needs to talk to the order, it talks to a function. So the other class will just expose inject itself into it, and then to communicate with it. No business logic that belongs to the order should be in the CAT. This is the gospel of the single responsibility principle. Loose coupling, because these services are loosely coupled, it means that changes in one will not affect the other. I had mentioned this before. If something happens, right, let's say our order service goes down, the recommendation service is up, the service that deals with the user interface service, the service that deals with the UI is still up, right? Only that service would have an issue. We won't have to take down the whole application because just one component has a problem. That is to my mind the biggest advantage of a microservice, because if something is wrong, we know exactly what is wrong and we can get straight to it and fix it, right? Of course, it reduces the risk of system-wide failures and allows us for more straightforward updates and maintenance. Of course, it's fault isolation. Following from this point, if something is bad, we'll just isolate that bad component and sort it out. We're not cascading a fault throughout the application. Independent security, of course, because each of these services are standalone applications. They have their responsibility, their security responsibility, their security needs are taken care of by themselves, right? It's like having different states in the federation called Nigeria, right? Where people said, oh, let us have state police. How many people remember that? Let us have state police. Oh, there's a bill in the National Assembly. Oh, and the guys in the say, oh no, we don't want state governors to have control of the security apparatus because they are going to use it to pursue their political enemies, right? Even though that was true, the underlying concern of that bill is right, because you want each state to be responsible for their own security. Does that make sense? Right? You don't want a state governor to be calling the IG of police to talk to the commissioner of police. No, you want the state governor to, right? In the same vein, because our services are standalone application, their security needs are implemented by them. Does that make sense? They're the ones in charge of their security, right? And then, of course, they will have an interface, an agreement that anybody who wants to talk to it must obey to facilitate exchange of information. Let's go over the points. There are several patterns, right? Design patterns of the microservices architecture, right? The API gateway part is just one. NCNC has raised a hand. We'll get to you. The database-based service is another pattern where each service has its own database. And let me talk a bit about number two. Please, if I'm fast, tell me that I'm fast. Because each services are independent, we can decide what persistent system we want to use, right? Do we want a document database, or do we want a relational database, right? Now, depending the read intensity of that service, that is what would determine what persistent system we are going to use. So if our service is read heavy, right? If it is read heavy, we would probably use something like a NoSQL database, right? Cassandra, MongoDB. But if it is write heavy and data consistency and integrity is our concern, we would most likely go for MySQL or Postgres or any of those kind of things. Does this point make sense? Let me hear. Does this point make sense? For number 2, okay, Elisha, go ahead.
No, I wanted to do the thumbs up. I went to do something else.
Okay. Right, because a question someone can ask you, okay, what would determine, like, what factors determine your choice of choosing a database for a service? There are several things. Is that service going to be read heavy or write heavy? If it's read heavy, okay, what are the persistent system that you can use that can facilitate that need? Now remember, every service has its core, how would I put it? Its core concern, right? What is the core? What are the core concerns of a service? That's what determines what database system to use. Number 3, we have the circuit breaker pattern, we have the event-driven pattern, we have the saga pattern. In the last event, we have can anyone remember? In the last event, we had demonstrated the event-driven pattern. Anyone? Does anyone remember? The event-driven pattern where the communication between the services are event-based, where if something happens in one, it would emit an event that will be listened to, right, from by another service or a group of services. Who remembers this? We had done this. Okay, I saw a few hands. And then of course the saga pattern. So okay, so this is the API gateway. This is what we're going to talk about today. So we'll have clients, and your client can be anything. It can be a web application, it can be a mobile application, it can be a wearable, right? A smart watch, a smart eyeglasses, right? Those are clients. Once they make a request, all requests are first intercepted by the gateway. Now think about this pattern as having a gateman in the estate, right? Having a gateman in the estate on your compound, in a big compound, and visitors come in. The first person or the first line of defense is the gateman, correct? If you have a gateman in your house, this is true across board, right? Person, or that's the first layer of security. In some states, especially in Lagos here where I live, you go through 2 or 3 gates, right? Now, once you get to a gate, they probably ask you, who are you looking for? And you say who you are looking for. Okay, does the person know that you are coming here? Yes or no? Right? You call the person, and the person will then call the gate. Now pay attention. You call your guest, and your guest, if they're at home, will call the gate to allow you in. Now remember, this is your first time in that estate, correct? This is your first time. You've not been there before, right? And then the gate man says, once you go straight, the first street on your right, once you get in, after 3 blocks, turn left, you see 4 houses. After 4 houses, turn right, you see a big house. Inside the big, does this make sense? So the gate knows what house you are going to, right? Now, of course, this is a simplistic version, but it was necessary to kind of give us perspective. The API gateway is the service that sits between our requests and our services, right? Database per service, we have talked about this before. Each service will have its own database. Circuit breaker pattern is a pattern that has a system and where it can allow for requests or stop requests depending on the state of that service. So if that service is down, right, it will open a connection. It will open it, right? If it is, and then continue retrying, right? If that service, once that service comes back up, up, it will close it, right? See, it closes on success, right, and opens on failure. Event-driven pattern, we had talked about this. One day, say with the producer and the consumer, and there's a broker in between. The broker has the channel, so a consumer subscribes to a channel. Once a service, once an action or an event occurs in a service, it would emit an event and then publish to a channel that one consumer or other consumers can receive that information. We had demonstrated this in our last class. The Saga pattern, so the Saga pattern is simply a pattern that eliminates a single point of failure. We're going to talk about this maybe sometime in the future. Okay. All right. So let's do a deep dive of that was just a recap of the last things we had talked about. So let's go into the meat of the day. Anybody has questions so far? NC, I think I saw your hand. Let's take a question before we go into the other thing of the day.
Yeah. So you were talking about authorization and authentication. Okay.
Yes, sir.
I wanted to know how other services would have their own, or how it goes about. Like, how would they know that, okay, this person is authenticated and all that?
Oh, good question. Okay.
My question.
Right. That's a brilliant question. So, if you were in our first class, you would remember I started the class by saying that even though the microservices pattern is a sort of a trendy thing, but it is not something that is meant for everybody, right? One of the core requirements for deciding whether to migrate your user base. How many people do we now have? How many active users do we now have? One, the dispersion of our user location. In what is the cluster? In what continents are our users mostly, right? So how many users do we have? Where are our users? And how critical are our services, right? If we have a payment service, for instance, you know that's a huge thing, right? If we have Netflix, for instance, you know that microservices is a must. So now, because of those concerns, we want to approach microservices very, very carefully. How would you normally, if you wanted to implement authentication and authorization within an application that is a monolith, for instance, what would you do? Well, you probably have user roles, and then you have protected endpoints, right? You have a middleware that sits before every request and then checks if the request has what it takes, right? Is this person authenticated? Oh, if they're authenticated. If they're authenticated, is this person that is trying to access this result, do they have the authority to do that? Well, how do you do that? You go to the permission that the authenticated user has and check. If I check against the middleware, this middleware is a contract, right? And checks with the middleware. If the person has a permission to be where they are trying to access, you give access. Otherwise, do not. What would you do? You'd use tokens. You use or the common one is come on, someone should remind me. The common one is JWT. You use OR, those kind of things. Now, who would be in charge of ensuring that this token is validated? That is the question we want to get into. So does that answer your question, NCNC? Just like you would in a monolith application, that service would have its own requirements.
Okay, so meaning the other services will be talking to a particular service to validate a user, right?
No. That service will talk to the API gateway. So that's what we want to start now. So you see, the other services do not know how the individual services implement their security. That's an important point to note. The other service does not know how let's say the checkout service implements its own internal security. Now remember, security is independent in a service. It is domiciled in a service. Does that make sense?
Okay.
Right? The other team can decide, you know what, we want to use Okta. The notifications team can decide, you know what, we want to use JWT. The recommendations team can decide. Does that make sense? It doesn't matter what you want to use, but the thing is that we almost have a contract that we implement, right? That will be enforced by the gateway. Now remember, the gateway is the one that knows what we all do. So I don't need to know what you're doing, but just give me a contract that I can talk to and give you what you require. So in that contract, I will know what you're expecting and I will give it to you in the format that you expect. Does that make sense?
Yeah.
All right, so let's get straight to it. Okay, so why NC you had very nicely introduced us to why one of, for the benefit of others, one of the basic reasons why organizations implement microservices using the API gateway pattern is to manage communication, right? Multiple services will need to communicate with themselves, right? It can be messy. I mean, I can tell you this even from trying to put together the microservices that we use for the class. Security, NCNC, can you see this? Security, multiple endpoints will be difficult. They will require different things. Now remember, if we have say, imagine that we have, oh my goodness, who's ready for this? Who's ready for what I'm about to talk about next? Who's ready?
We are ready. We're ready.
Who's ready? All right. Imagine that we have 20 services. And that application is not just a microservice, it is also a multi-tenant application. Take 2 minutes. Think about it. Do we know what a multi-tenant application is? A multi-tenant application is an application that serves multiple tenants with the same code base. So so let's say Alicia, Alicia, please give me an example of a multi-tenant application that is in production.
That is in production as it's currently running, or an example.
Yes, any example at all.
Yes, school management system.
Yes, school management system, client relationship management system.
Good. Good. So imagine a multi-tenant application that is also a microservice. Think about it. Please unmute your mic and say something. Think about it. What level of complexity that would be? Anybody?
A microservice. How would a microservice now be a multi-tenant application? Is that not
good
over engineering? I mean, just thinking about it on a high level, it looks like it's over engineering for me. Microservices and then multi-tenant still, because I mean, I feel the concept of microservices is breaking out one particular service or action for one thing to take care of personally. So why are we breaking out and still complicating it by making it multi-tenant?
Good question. So in preparing for this class, I stumbled on an article, a write-up that that basically described how Netflix. First of all, remember, Netflix is not a multi-tenant application. But guess what they tried to do? The initial plan was to make it such that every country is a tenant. Think about it. Every country is a tenant. So they will serve Nigerian users content that is close, the content that exists on a server that is close to that continent, to that country. Does that make sense? That's one use case. The other use case.
Yeah. Sorry, let me contribute if it's fine. I've just maybe like
Yes,
question. So if
yes,
you're bringing in the Netflix example here,
yeah,
I read somewhere and then I saw something like sharding and then geo
yeah,
sharding. So would that not just mean having maybe like a movies microservice, but decide what DB to connect to based on the geographical area? Like,
location.
wouldn't that be much more
Absolutely.
explanation than using multi-tenancy? Because if you're talking about multi-tenancy now, in the case of Netflix, it will mean that Nigeria is a tenant.
Yes. So I'm sharing with you what the article basically attempted to expose to us the thought process of the engineering team at the inception, how they went about the process of deciding what structure they settle for eventually. So you know how it is, you go through different iterations until you find what works, right? They attempted to treat countries as tenants, right? But then it did not work because of different things like pricing, right? And while we are at the topic, I hope you guys know that the Nigerian pricing is cheaper than the US or the UK pricing, right? What you pay here is lesser than what others pay. So Nigerians come here, register accounts, and then go over there and then use the accounts. So those kind of things make them realize that those things will not work, right? So let's go on to another use case. DigitalOcean. DigitalOcean is a multi-tenant application. But guess what? DigitalOcean is one of these few teams that are also a microservice. So I am not completely sure how they achieved it. I'm still reading about it, but it seems it is over engineering for sure. But then there's a method to the madness, right? I'm interested in seeing how they did that, how you are going to treat a tenant, and then after you realize who the tenant is, then you then separate the request to the service depending on what that client needs. Okay, so maybe we'll talk about this another time. In fact, I encourage others to go and read about it. Is it possible to have a microservices application that is also a multi-tenant application? Please, if you find articles or you find videos, please share it on the group. I would like to also look at that. Okay. Sorry, did this conversation help anyone? Did it help anyone?
Yes, it did. It did.
All right. Okay. Please read about the possibility of having a microservice that is also a multi-tenant application and see how that has been achieved. Okay, let's proceed very quickly. Load balancing. That's one of the reasons why microservice. So Elisha, you see that load balancing is a core part of the API gateway pattern. If you're not using load balancing, then you resort to what I was talking about earlier, which is duplicating the making several instances of that service. Elisha, I don't know if you don't get what I was saying. So load balancing is it depends on what pattern we decided to use. Okay, Elisha, and
Okay, not to derail your thought process, but in this case, if we're looking at an API gateway and a load balancer, are there not distinct differences between them, right? because my basic understanding of what an API gateway with respect to microservices is that it's a way for, let's say the user makes a request to the app, the API gateway decides what microservice to send that request to.
Yes.
Decides what microservice to send that request. So meaning it has to be specific based on the request. So if I'm looking for movies, it has to pass the request to the movies microservice. If I want to make payment for my subscription, it should know to pass that a request. Exactly. But now if we're looking at load balancing, it's just same request but distributing it to different servers that does the same thing. Now the main load balancing is all these servers does the same thing. It's just to ensure you're scaling. But for API gateway, it has to know what exact microservice to send it to, not just maybe using round robin. So is there no clear difference, or is it just conceptual terms and all?
Good question. Now, so you see, the API gateway has core functionalities. It has what it does. You know, remember, it is a service on its own. Like it's a standalone application on its own. So security is part of it. Now, communication is part of it. Load balancing is part of it. I'll share resources, you know, so we can, I'll share resources on the group so that we can read more about it. Service discovery is part of it, right? So let's go over it again. Handling communication. A request comes, it takes that request and knows from the inspects the URL, knows where that knows what service that is going to, sends it there. That service does what it needs to do with that request, returns a response through this API gateway, and the API gateway returns that response to the client. Security. Once the request comes, it determines if the request has embedded in the request, if it has the tokens demanded by the service that request is going to. If it doesn't, no need. It won't even send it to the service. It would return a response. Load balancing is also a functionality of that API gateway. Now, how does load balancing happen? Maybe we should even talk about this. So let's imagine that to a Black Friday example. Now, depending on what service we're using, right? What cloud service provider we're using. Once it determines that we are receiving a lot of requests, it would scale automatically. Now, that duplication of service instances is the service provider. Before now, you know, the engineering teams will have to write some code or script that would determine, that will look at the request, look at the load of the request, and then, you know, that script will automatically spin an instance. But, you know, the service providers now, we will do this for you, and as a service offering, right? You see, if you go to some cloud platform, they will tell you, automatic scaling, automatic load balancing in some cases. Before AWS will tell you that they will scale your application for you, they will do load balancing automatically, right? Now, so once you have multiple instances in a cluster, your gateway would, remember, all requests are passing through the gateway. So if you have 1 million requests or you have 10 requests, who will know? The gateway will know, because all requests are passing through the gateway. So what the gateway does, it sends those requests to the different instances. Again, I'm going to share resources to help us understand this point. In fact, maybe I should even do that now. There's something on the group. There's one on the group. There's another one on the group. I'm going to share another one recently. Please confirm that you can find 2 links on the group. can find two links on the hasn't delivered yet. Can you guys still hear me?
Yes, you can see
Can you
you.
guys still hear me?
Yeah.
I hear you. I hear you.
Okay. All right.
They drop the link to the group just in case anyone is not on the group yet.
Yes. Oh, great. Okay, you have done that. Okay. So load balancing is also a requirement. It's also a core functionality in an API gateway. Okay, let's proceed. All right. An API gateway acts as a single entry point for all clients, routing requests to appropriate microservices. Now, so back to Alicia's point. So if we have multiple requests, like our server is inundated by this a barrage of requests, the first person that not person per se, but the first service that will know about this as per the volume of requests will be a gateway. So it acts as a single point for all clients, routing requests to appropriate microservices. So let's talk about core functionalities of an API gateway. It redirects requests to the appropriate microservices. We'll talk about that. It distributes the request. So you see, this is the core point, Alicia, to your question. Alicia, are you still here?
Yes, I'm here.
So the core point is not that it does it is the first, like the first point of entry. So its job is to just distribute it. It is not the one processing the requests. Elisa, does that make sense? So you can think of it as load balancing being a two-tier system, right? It has two components. The person who receives the request receives the barrage of /order, so whatever /order /order. So he knows that it has received 10,000 /order requests and is going to the other service. But guess what? It also knows. Now remember, every time a service starts up, right? The first thing each service does is to do something called service registry. It registers itself with the API gateway. Registers itself, including the port. So the gateway will have an array. So let's say our order service, right? Depending on what we're using, we can use a caching mechanism or persistence like storage, right? So if we have, so the other service will have an array, and then it will have the ports of all the instances. Do you understand? So let's say the first one was up. By the time the next one is spawned, whoever spins it, whether it was our code or the service provider, in this case AWS or GCP, by the time that service comes up, the first thing it does that it, and this is the port I am using. Another one spins up, it registers itself. Another one spins up, it registers itself. So our gateway knows that the other service has 10 instances with 10 different ports. Does that make sense? Does that work? Is that clear? So the key point here is distribution. It is not the one doing the request itself. Doing the what's called load balancing itself. Security, it manages authentication, authorization, and other security measures. So let's talk about this for a minute. So because now remember, our gateway service is a gate man, right? It knows everything. It knows it knows the security requirements, the authentication requirements of all the other services. So it has that blueprint, right? We are the other service, the other guys are the notification service. Then we submit our requirements, as it were, to the gateway service. So it knows to say, oh, if somebody comes with an order, please check that they has a a 32 or whatever digit token and it is signed or whatever, please, if that, only send me that request if that token is valid. And here does that work? So the service knows that it has that requirement. Rate limiting. Now, Elisha, this is to your point. This is speaking. That's why I loved your question. So you see, rate limiting is one of the key, one of the most important components of designing APIs, right? Your API should be designed in such a way that it can increase the longevity of that API, right? Its role is to ensure that your endpoint is not receiving too many requests than it can handle, especially from the same IP. Rate limiting can save you trouble, especially, in fact, even with security problems. Guess what? Who else can do that for you? The API gateway. So let's go back to our order service, rising from Alicia's question. So let's say it has 10,000 requests per. Our service should not allow 10,000 requests to go to all 10 clusters of our order service, all 10 instances, right? It will crash. But it has to do it in such a way that it will reduce that latency. Caching stores frequently accessed data to improve performance. Lisha, do you want to talk about this caching?
No, Lisha, no, I want to listen.
Okay, so let me explain. So in your implementation of caching, in your implementation of an API gateway, caching is one of the things that you can do to improve performance, improve page load speed, and reduce latency to as little as 1 second or less than a second. So right. So let's say one of the things you want to do is cache static data. Static data is data that will not change. It's not dynamic, right? So let's say the API gateway sees that, oh, people are demanding for shoes, Nike shoes, for instance. It has seen the pattern of that request, right? And then it has come more than 500 times. Well, the first thing it will do is to cache that response, right? It will put it inside, like, so caching just means that it reserves a copy of that data in its own service. Does that make sense? It retains a copy of that data with the condition that it hasn't changed, right? So when so subsequent requests for that Nike shoes, guess what? It will not go to the product service. It will get that data from itself. Does that make sense? Does that work? Is that clear? So 500 requests, 500 people are asking for Nike, and the API gateway has seen this to say, oh, okay, maybe this Nike is in demand. Oh yeah, bring the data and save it here. Subsequent requests, I'll retrieve that data from myself, and if it's not there, then I'll go to the product service. Lawa was like, you have a question? Go ahead, Lawa.
Yeah, in case there is a change in that particular product, how will it actually, it has already stored it as a cache, like you explained.
Yeah.
So how will it actually being notified, or I don't really like how it actually work if there is a change in that, maybe in the description or in the prices of that particular product that has been
Good question. So the caching works in such a way that if there's a change, remember, it will only go to the products if it does not find it. And if there's a change, the next time around it fetches product data, it will update its cache.
Okay.
So so understand, it will not always remain like, it will not always go to its own persistence layer to get that information. The implementation works like this. Check if I already have that information, serve it. If not, go and retrieve it. Now remember, as it's going to retrieve, it's going to bring other things that will update what it currently has. Remember, each information has a key. It's like is a key value pairs, right? It's saved as a key and value pair. As it's going back the next time, it will retrieve information, new information, and update the cache. Okay, I think we have. Let me open the queue. We have hands here. Lawal, Sheriff, let's take you first.
Oh, sorry. That's my question. Maybe I'll just take it off.
Okay. Who else? Elisha.
Yes, I want to contribute to what you answered to this guy. So when you're using a caching layer, you risk stale data, but I think from how it works depends on your design, sir. When you're writing to the storage, it's always best to update your cache. So whenever there's a write request, you update your cache. So whoever is reading from that cache ensures that they are reading good information. So when you make the latest information. So anytime you make a write request that updates that particular cache record or database record, you update the caches that you have to read. Yeah. Else you would have stale data. It's up on you. It's up on you to take that action of updating it. So you should have that one at the back of your mind.
Absolutely. Okay. Thank you so much, Elisha, for that point. So let's flesh out his contribution. So let's say the new versions of Nike. Now remember that the API realized the gateway service realized that there's so many calls for Nike, right? He's saying that every time there is a write request, that write request subsequently updates that cache. Does that make sense? So you have a write request, you update the cache. Okay. Next question. Elisha, your hand is still up. I don't know if you have a question, or Elisha, your hand is still up. We can proceed. Okay. All right. Okay, so what are the benefits of using the gateway pattern? Right? It simplifies client communication. It reduces the number of round trips between clients and services, right? It manages security, logging, rate limits centrally. It hides internal service details from clients, adding an extra security layer. With caching and load balancing, it improves overall system performance. Easier to monitor and manage traffic through a single entry point. So should we talk about this? Should we flesh out these things one by one, or it is clear? Please unmute your mics and say something. Should we flesh them out one by one, or it is clear? Should we flesh them out
one by one? One by one.
Okay. Okay. Who else?
Yeah, it's one by one. Yeah, one by one.
All right. Okay. So you see, Elisha, the thumbs up. What does the thumbs up mean? Okay. I can't hear. All right. So let's do.
It means
so you see.
Let it out. Sorry, I mean noisy.
Oh, okay. All right. So you see. I don't know how many people were in our first class where we demonstrated, let me see, where we demonstrated, an order is placed, a product service would you create a product, then when somebody wants to add to cart, They will add, before adding to cart, the cart service will first of all go and check, make a call to the product service. Oh, this product or products that this user wants to add to cart, does it exist? If it exists, it will return. It returns a boolean and then says true before it will allow it. Then after that, before adding to cart, that is done. Then at the point of checkout would now confirm from the cart service, this product that this person wants to check out, are they with you? If they are with you, it will proceed. Otherwise, it will not. Then the inventory service, before checkout happens, it will talk to the inventory to say, hey guy, this quantity, do you have it? Should I allow this guy to pass? The inventory service will return a response and say, oh, well, yes, I have it, or I don't have it. It will return a response to say, you already see how messy that is. Each of these services are, the chain of communication is huge and massive. And now remember, this is just for 3 services, local services that we have on a computer. So imagine how messy and complex it can be. But if you have an API gateway that knows about each endpoint per service and knows about what it returns, it is easier to simplify that communication. So a service that would normally need to talk to 3 other services will only speak with one guy. Centralized cross-cutting concerns, manages security, logging, and rate limiting centrally. So if you had so let's say we have 5 services and we have an API gateway, because remember they are developed as a single standalone application, and as single standalone applications, we are responsible for implementing our own rate limiting, our own security, our own logging, our own, name it. But we can say, okay, you know what? Since we have an API gateway, maybe we should not bother about rate limiting, right? Maybe we should not bother about logging internally. Remember, this is us. How many are we here on the call? We are 17. So we divide all 17 of us to groups of 3 each, right? We can decide we don't want to do logging. That would be too much work. We don't want to do rate limit. Let us leave that to the API gateway, so that once we, if somebody wants to know what is happening, the API gateway will have an endpoint that will tell us everything that happened in the notification service or the other service. Improve security, hides internal service details from clients, adding an extra layer of security. So let's say we do not have a gateway, and of course, remember, all of us, because we are responsible for different services, we will implement our own security, right? And I'm a service. I'm part of a team that has a service that needs to communicate with 4 services. So remember, checkout, for instance, we'll have to talk to inventory to see if the quantity is still there. We'll have to talk to cart. Do you have that in the cart? We'll have to talk to product. This product that they are trying to buy, do you even have it? Remember. So one service that needs to communicate with 4 or 5 or 6 services would also need to implement whatever security standard those services demand. Here we're just talking about communicate with 4 or 5 services. We are ignoring the fact that 1 or 2 of the services might have their own security requirements that are different from other services. Does that make sense? So let me explain further. This is checkout. Maybe Elisha is products. Abdullah is inventory. Ayeni is carts. For checkout to work, I'll need to talk to Elisha, Abdullah, Ayeni, right? Now, I am just saying talk to them as though they don't have their security requirements. So guess what? In talking to them, I have to give Elisha what he wants, give Abdullah what he wants, and give Ayeni what he wants. Does that make sense? So, except all 3 services are using the same security standards and protocols, then I'll write one requirement for all 3. But guess what? If they all implement different security standards and protocols, I'll need to give all of them different what they're looking for. So you can already see how having one entity that simplifies security helps. Does that anybody understand what I'm talking about?
Yes, yes.
You understand? So instead of you giving Elisha what he wants, giving Ayeni what he wants, giving the other person what he wants, and remember, they could be different. They could be looking for different things in different formats. Don't even forget that. They can be looking for the same thing in different formats and using different security implementations. So that code from the checkout side, we need to have a meeting in the whole organization and say, okay, please, you that you're looking for this, what format do you want it? They will send us their requirements and format. The checkout people, the inventory people, what format do you want your do you understand? So it's not just the different security standards, we have to implement them the way they want it. So by having one gateway that simplifies that, we hide all that detail. Better performance, we have talked about better performance with caching, load balancing, monitoring. By having an API gateway, we can monitor. We can know how many services are up. So we have 5 services, for instance. We can know that, oh, we can call the health. Now remember, I'm going to show maybe if this time, each service will have a /health endpoint that says, that lets us know that that service is up, right? So the API gateway, maybe we can, depending on how we want it, we can say every 10 minutes, do a call to the /health of product to find and let it return a response. We can know at every time which services are up. Guess what? We can know at any time which instances of a service are up. Black Friday implementation, order service has 10 instances, right? Maybe not all of them may be up. It doesn't mean that the service has failed. Let's say they were 10. Let's say 7 are up and 3 are down, right? The gateway will know which is down, because remember, each of these instances have their /health. Do you understand? So let's say the product service has 800, 8001, 8002, 8003, 8004. All that is product service, instances of the product service. So the instance at 8001 has its own /health endpoint. The instance at 8002 has its own /health. Does that make sense? So each instance has its own. So the gateway will know, okay, the other service is up, but which instances are up? Are all 10 of instances up, or maybe just 7? So that's enhanced monitoring. And then of course manages traffic through a single entry point. So let's talk about the architecture of this pattern. Please confirm that you can see my screen and that this is legible. Please confirm that you can see my screen. Good. Now, guys, I recently just figured that there is a service that handles the UI. I did not know until last week. Do you understand? Can you hear me? Can you hear me? Can you guys hear me?
Yes, I can hear you.
I said I recently realized that there's a service that deals with the UI. So we can hear you. Yeah, so there's a user interface. The user interface is controlled by a service itself. Okay, so you see that the request come from a client, hits the gateway, right? And these are specific endpoints. This is a single entry point, and then the gateway redirects the request to API redirects the request to the separate services. So let's even go through the components of a service, right? You have the client interaction, the client application. Remember, it could be your web application, it could be a mobile application, it could be a watch, it could be a wearable, it could be a car, right? You know, we need to begin to talk about how we can write code that talk to physical devices, especially ECUs in cars. That's a separate topic for another day. Of course, you have a gateway that manages all incoming requests and routes them to appropriate services. Then you have the back-end services themselves that handle the business logic, right? The individual services themselves. And then, of course, you have the database of each service. So each service has its own database. This one can have Mongo. The other one can have MySQL. The other one can have Postgres. The other one can have Cassandra, right? And then you need a system to discover, a mechanism to discover the services, right? Some way for the gateway to know where the services are. Okay, does anybody have any question on this slide? Anyone has a question? Or can we proceed? Let me see a thumbs up if I can proceed. Let me see a thumbs up if I can proceed. Good. Okay, Samuel, that's good. So let's even talk about how we can implement the gateway pattern. Choose an API gateway solution based on the requirements. It could be, you know, the core requirement could be scalability or ease of use, or you have a feature set, right? Set up that gateway, install and configure a gateway. By the way, they are third-party gateway services that you can just, you know, use out of the box without having to write your own from scratch. Then you define the routing rules and load balancing strategies, right? These load balancing strategies are how you want the gateway to distribute the requests. Now remember, the gateway is not the one doing the load balancing, depending on your implementation, that is, right? Then you integrate security measures, implement authentication authorization, configure rate limiting and API key management. This just means that there has to be a structured and articulated way for talking with different services. So your API gateway needs to have a key management service, like some way for you to exchange API keys with services. Enable monitoring and logging. This is easy. You're just logging activities. Once a call comes in, you log it. You can use third-party tools to track the metrics. Of course, you can deploy the gateway to your environment and then test with different client requests to ensure proper routing and handling. So let's quickly go through best practices. You want to decentralize your business logic. Keep the gateway simple. Avoid implementing business logic within it. This is a common mistake, right? Use TLS or SSL for secure communication. This is a no-brainer. You cannot talk about security in microservices without using any of these standards. Of course, implement rate limiting and throttling. Implement this to prevent misuse and protect your back end from incessant requests. Now, remember, these days, right? I hope you guys know, cyber attacks these days are not done by humans anymore. They are done by scripts or even AI-powered scripts. So one of the things that can protect your service is a well thought out rate limiting and throttling strategy. Of course, monitor and log, continuously monitor. You don't want to monitor and log everything. Otherwise you won't be able to make sense of the data, right? Except you have another service that makes sense of that data. So you need to figure out what metrics are important to you and only log and monitor those metrics. Scalability, ensure the gateway itself can scale to handle increasing load. again, we've talked about this. Is either depending on the cloud service provider you want to use, AWS, GCP, or whatever, which will then handle scaling, and in most cases load balancing. You then have to say, oh, if you see requests up to this amount, please create another instance of that service, right? I don't know if this makes sense. You are the one to define what parameters would trigger the creation of another instance, right? Are you going to say, oh, when you see 10 requests, or you spin up another instance, or when you say 500 requests, or when you see 1,000 requests? Does it make sense? Do you understand this point? Please unmute your mics and then speak.
Yeah.
You have to decide. Otherwise, it will just spin up instances without your knowledge or control. Versioning. Manage API versions to handle backward compatibility and updates smoothly. This point is clear. All right, so let's proceed. These are the references. I have shared the references on the group. I'll still share more. Okay, so anybody has any question? I would like to take questions now. Have any question? Please get the time. Let me attempt to share. Anybody has any question? I'm trying to share the code. I'm trying to share the screen of the code. Please, if my background is noisy, please bear with me. Anyone has any question? Questions? Questions going? Questions going once, going twice.
Please, can you come again about the circuit breaker? Like, how does the circuit breaker, the pattern, circuit breaker pattern?
So
please, can you come again about that?
Okay, so we are not talking about the circuit breaker pattern right now, but I am happy to share with you resources that will help you understand it. So what I meant was questions regarding the class, what we just finished. Anyone? Questions regarding the class, Java Workspace? No. Anyone has any question regarding the class, what we just finished?
Yeah, hello.
Okay. Yes. NCNC.
Yeah, you didn't give any example of this API gateways for third parties or any examples.
Any example of the third party API gateway?
Yeah.
Okay, let me just quickly do a search. But I know that group. Okay, so third party API gateway. So I know that Eureka is one for Spring Boot, Java Spring Boot. Eureka is one. Zuplo is another. I'm just going to share. Okay, I'm going to share a link right now to help you.
Okay, thank you.
All right. The link is in the group. Okay. All right, guys. So let me try. Now, this class is not the demonstration of the API gateway. I'm just going to demonstrate a few things, right? But maybe next Sunday or so, it will give me time to sort it out, right? I've had problems with this code which that's why I'm asking for another week to sort it out. Okay. Right. This class is not. I'm not going to go into it per se. I'm just going to show you how like a preview of what it will be next week. Right. Please confirm that you can see my screen.
All right.
Confirm that you can see my screen. Confirm that you can see my screen. I think we're doing good for time. Confirm that you can see my screen.
Yeah, we can see your screen.
I can see the screen.
Good. All right. So this is the API gateway. This is the checkout service. This is the inventory service. This is the payment service. And then this is the product service. And this is the user service. All right. Let me share my entire screen so that it will work. Stop the share. Share again. Share my entire screen. All right. Good. So let's go over this. This is 8,000. This is the product service. Confirm that you can see that the product service is running on port 8,000. Can you all see my screen?
Yeah, we can see that. 8,000.
Yes, we can see that.
All right. This is 8,001. Please confirm that you can see that the inventory service is running on port 8,001.
Yeah, we can see that.
Good. This is the checkout service. Please confirm that you can see that the checkout service is running on port 8,002.
Yes, we can.
Unmute your mics, please. This is this is the API gateway. Please confirm that you can see that the API gateway is running on port 8,003.
Yes, we can.
Yeah.
Good. Good. All right. I'm going to can you see put that Postman is up?
Yes, we can.
All right. So I'm going to send this request. This is services. 6 services. Okay, I'm going to flush it. All right, I flushed it, and then let me check the services. No services available yet. So good. So this is the API gateway, right? Just checking that this is an endpoint in the gateway. Just checking how many services are available, right? So you can see that no service is available. So let me. So I'm going to turn off this service, right? You can see that it's no longer running. I'm going to turn off this one too. Inventory is no longer running. I'm going to turn off checkout. Checkout is no longer running. I'll only leave the API gateway itself running, right? Please confirm that you can see that the product is no longer running. Unmute your mics. Unmute your mics.
Yes, we can. Yes, we
Yeah,
can.
Confirm that you can see that the inventory service is no longer running.
Yes, we can.
Okay. Confirm that you can see that the checkout service is no longer running.
Yes, we can.
Yeah.
Confirm that you can see that the API gateway is still running on port 8,003. Good.
Yes,
So once
yes.
I come here, good. Once I come here and check, okay, there's nothing running. The 8,003 is still running. There's nothing there. All the services have been flushed. I want to check, okay, no. Let's close everything else. Okay. Now, so I am as soon as I turn on the product service is going to register itself with the gateway service. So you see, now when I check services, there's nothing there, right? As soon as I hit enter and serve the application and the product service is up, we're just waiting for it to come up. I'm not sure why it's taking this long, but okay. Please confirm that the product service, they can see that the product service is up on port 8,000.
Yes, it's on.
Okay, so now let's go and check this service again. The first thing it does is register itself with the gateway to say, oh, I am here, and this is the port. You can see. Can you see? Maybe I should increase the. Can you see?
Yes, we
Can
can
you guys
see.
see?
Yes.
Yes.
So let's.
Yes, we can see.
Okay, cool. So let's go to the code. How is that? How is it doing that? Product service. So how did I do this? The first thing I did was, I went to the provider. I created a provider called service registry, right? Service registry is a simple thing. It just registers the service. Now, let me go to the service registry service inside the product service, right? So this is the product service. Confirm that you can see service registry service. It's just a service class. It doesn't mean that it's a microservice. Now, pay attention to what it is doing. It just grabs the service name, product service, grabs the port. In most instances, this port is going to be dynamic, right? But for the sake of this class, for the scope of this class, it's hard coded. Now, and then this is the service URL, right? Slash. This is the domain name slash the ports, the name of the port, right? Slash the API slash product. Now, where did I get this from? Okay, good question. Remember, there's a prefix called product. So the product service has a prefix slash API slash product slash whatever slash API slash product slash health slash API slash product slash products. Do you understand? That's where this is from. Please, do you understand what I'm saying? If you have a question, just ask. Good. Then I am making a post an internal HTTP call to the API gateway to register this service. Look at it. I'm just making a HTTP post and I'm registering the service, right? Then this is just logging to the I'm logging to the log here. I'm saying, oh, project, yeah. There you go. So you see the logs I was talking about here. A lot of things has happened, but let's see. Look at it, right? You can put this in the data. You can decide to put this so that you can see at what time this happened. So you can see the log has a time. Okay. All right. So is this clear, or do I need to explain further? Now I'm registering. So this service class that you see here in the product service, I have come to the service provider, right? This is our providers now, and then I'm binding the service registration service class to the app container, so that anytime at startup it will happen. That is how this is successful. So if you run it again, you see that it's only the product service that is up, right? Please unmute your mics. So let's go and start. Let's go and start the other service. Okay, so let's keep doing this. Let's keep calling it. It's not there. Oh, we have the inventory service. Please confirm that you can see that the inventory service has registered itself at the point of startup.
Yeah.
Yes.
Okay. Now the API gateway now has a total of the services that are available. You can see. Can you see this?
Yes, yes.
Good. So I am demonstrating service registry, right? Then maybe next week I'll share the challenges I'm facing here, so that if anybody has a solution. So the checkout service is now going to be up. As soon as the checkout service is up, it will register itself. So let's check. Boom. So you see, checkout service and say, oh, I am here, then the APS, the gateway now has a record of the 3 services, right? Is that clear?
Yes, it's clear.
Good. So let me go to the API service itself. So what I just showed you guys here is what is happening on all the services. All the services are doing the same thing. At startup, they will register it. So let's go to the API service and see what is going on. Now, how am I registering? I'm using the cache. I'm not persisting it in storage. Now, the reason you don't want to use storage is because the services might change. It might go down at any time. The ports might change, right? So I'm using a storage. So let me quickly run through the code. So this is the again, the way I structure my code, I separate the repository from the service, I separate the service from the controller, I separate the controller from the DTO, so it's modular that way. I mean, if you need more, if you want to find out more about this, talk to Daniel. Daniel knows exactly how this works. Okay, so the services just gets everything from the register, from the cache, right? And then for each service, I'm getting the service name as this, and then putting that service data in the service name. This is just very simple. I'm looping through the service that I'm getting. This is how I'm creating the service. I'm receiving the service name. Remember that service provider. Remember what you were doing before. Who remembers? See the service name, the service port, service URL. And then I'm sending it to this guy, that's a register. So this is what the registration does, right? Where is it? Service repository. Now this is the service repository in the API gateway, right? I'm simply just grabbing everything and saving it here and then putting it in the cache. And then the key is called service registry, right? Then get registry from cache is simply getting everything using that key, or it returns an empty array. Get registry by name is, if I want to find out the registry by the name, I'll simply pass the name. It will give me that service, right? Flush is just taking out everything in the cache. Updates it. Now, this is that thing that Elisha was talking about earlier. I don't know if Elisha is still on this call. Elisha, is still on the call?
No, I'm not sure.
Okay. Now, remember when he talked about updating the cache at every time you want to write, every time you have a write request? Remember, someone had asked a question regarding how to keep the cache updated. Remember, and then he said that one thing that happens is that you always update the cache every time you write it. Who remembers?
Yeah, I recall.
Yeah, I recall.
Good. So look at it here. Look at it here. After I write it, after I save to it, I will always update it. On line 41 is where you update it. Can you see? Can you see?
Yeah, I can see.
Good. So put is just doing the same thing. Okay. What else? Now every endpoint has its check, and every service has its check endpoint. So this is the problem I was having. Let me share it with everyone. So in the controller, in the service discovery, service registry, right? There's something called check. And this is the problem I am having with check. So let me share with you. Maybe someone can help me out. It will really help out. In the discovery, right? Remember, this endpoint that checks all the services is a discovery. Is part of this discovery class, basically to discover a service, right?
Yes.
Good. Now, I am trying. The problem I'm having here is this place. Please, I like you guys to open your eyes and then pay attention to it, because I feel like someone might help me with this bug. So I have a bug, right? here, what I'm simply trying to do is that I'm trying to get the health URL. So let me explain what a health endpoint is. A health endpoint is simply an endpoint that determines to check if a service is up. It just says I am healthy. So let's us go to let's find out if the product service is up. So you see /API/product/health. Let us send it. Once we send it, we'll get a response. Oh, right? Okay, same thing. Let's go to checkout. Once we go to checkout and go API/checkout/health and hit it, it will say, yes, I am healthy. So you can see that that health endpoint is up and it's working, right? Now,
yes.
once I go to inventory and hit check, it will say, oh, I'm available, I'm up, and I'm healthy, right? But in the gateway service, once I go to check, right, the aim of this service is this endpoint is just check all of them and then return a response. So here's what I'm doing. I am getting all the services and then retrieving the service URLs /health and then making a call to that health service, basically what we just finished doing, right, individually. So I'm trying to do it here. If the response is successful, I will attach healthy to the status. Otherwise, I will attach unhealthy to the status. Does that make sense?
Yeah, that makes sense. It's just like a mini test, something like that.
Yes, a mini test. Good. So let's look at the code. Then after that, updating the services. Let me even go to these updates. This update is here. Simply updating it. Just okay. Then health check perform success. So let's hit this check endpoint again. Can you see?
Yes, we can.
Can you guys see the problem I'm facing? So it returns an error saying that the maximum execution time of 60 seconds has been exceeded, right? So maybe I should, maybe I should share this code. All right, let's remove this and try again. Same thing. It will return the same error. Well, let's just wait for it to finish. Then after that, we'll take out this timeout. I'm not sure why it is doing that. We have just tested the individual endpoint and it is working. So I'm not sure. Maybe if you think that you can solve this problem, hit me up and then let us look at it together. It shouldn't take this long because Yeah, because what it is simply doing is that making the making um the the call to the endpoints themselves. Or you know what? Let us even log this health check and see.
Have you tried just doing it with just one endpoint?
Like check each.
Like just checking one to know if it's actually one is even going through at all.
Yeah, but we just did.
Like with this particular
code.
Gate check. Let's just check only one. Let's just see if one will go through.
Okay. All right. Good point. Instead of doing for each service, so let's do one.
So let's go if
all right. So let's do
initial one.
Yeah. So let's do let's do products, right? Product is okay, so this is the product endpoint. Let's put it here and then take everything out and just do gets. All right. Okay, so let's comment out everything else. Comment out the for loop. Wait, let's find out where the for loop is.
I think I just break at the end of the first for each, so you just don't need to I just break out of the code.
Break out
of the for each loop. So that when the first try is done, so we just break out of the for each loop. On that day, after you updated, it appends the service to the updated service. You can just break out of the code. So then it's like
so this is the health service, right?
Yeah.
Let's do this. Check. Let's go to check now. But before we do this, let's come here and then storage logs. Okay. So I don't want to check. So you see, it returns it, but then says unhealthy, and this is not correct because the endpoint is up, right? So right, it attaches unhealthy to it. Oh, so this is the problem. /health. So that's why you log it always. Okay. So it has given us the problem. All right. So let's try it again. So who has seen what I've seen? There's meant to be a /health here.
Oh yeah,
right?
true.
Yeah. So let's leave it there and then try again. Desculpe. Okay. Same thing you're saying on healthy. So, okay, maybe we can. So yeah, so you see, this should work, but it isn't. Okay, so we can circle back. We need to close so that others can go. We can circle back, and then if you think that you can sort out this bug for the whole class, just let me know, DM me, and then we can go through it together. Okay, so once we're able to sort out that problem, we should be able to sort out that problem this week, and then we can continue next week. God willing, we'll do the demonstration and show how it works. All right, everyone, thank you so much for spending time with us.
Yeah.
We started with 17 or 20 something people, but then I'm not sure how many people we have left. Okay, if anybody has any questions before we close. Have any question?
Oh, from my end, no question. I think, yeah. Thank you everyone for joining tonight's session. We really appreciate you staying till this time. I hope you've learned a thing or two about, the gateway pattern, API gateway pattern in microservices. And, like you said, we'll have to still go dive deeper, into the practicals and see how, it works under the hood. Thank you so much for joining. Thank you, Mr. OBD. Thank you, Mr. Samuel. Thank you, Mr. Jackson. Thank you, our boss, Bosun. Thank you for joining tonight's session. We are really grateful to have you. And thank you once again, Mr. Nelson. Have a great week ahead and see you soon.
All right.
Thank you very much, everybody.
Yeah. Good night.